going to do long division for polynomials, where we divide a polynomial by another polynomial. And then after that we're going to look at synthetic division, where we use an algorithm to basically do long division in a simpler way. So we're going to start with this example. We have a polynomial x squared plus 5x minus 14. We're going to divide it by x minus 2. So I set it up this way for long division. X minus 2 here, and then the polynomial x squared plus 5x minus 14. So we take this this variable with the highest exponent term, x to the 1. So x into this term, x squared, gives us x. X times x is x squared. X times minus 2 is minus 2x. Just like regular division now, we subtract this bottom. 5x minus a minus 2x would be 5x plus 2x. We get 7x. X squared minus x squared gets rid of that. It's a 0. Now we carry this down, minus 14. Now we divide this into this. We get x into 7x gives us 7. 7 times x is 7x. 7 times minus 2 is minus 14. We take minus 14 minus a minus 14, minus 14 plus 14, it gives us a 0. 7x minus 7x is a 0. So it comes out even. So the two factors that make up this number, if we divide this number by x minus 2, we get x plus 7 with no remainder. Remainder of 0. So the factors here are x minus 2 times x plus 7. So that was using long division. Now, let's erase that and let's try synthetic division instead. Okay, we've used long division on this problem. Now let's use synthetic division. And to do that, we've got this polynomial function divided by this factor. So for synthetic division, we'll have x equal to 2. Put that here. And then we'll take the coefficients on this polynomial. So we'll have a 1, and we'll have a 5 from the x term, and a minus 14 from the constant. We'll carry this first coefficient down. Then we'll take 2 times that, will give us 2. Add those, we get 7. We'll take 7 times 2, which will give us 14. Add those two, and we get 0, which would be the remainder. So by synthetic substitution of this x equals 2, we end up with a function of 0. So function of 2 is equal to 0. Okay. In addition to that, synthetic division tells us that this 1 now would be related to the x term. So we would have x, and 7 is related to the constant, so we'd have plus 7. And there's nothing else. We have 0 beyond that. So when we divide by this factor of x minus 2, this is the factor we end up with. So we've actually factored this polynomial now. We have the x minus 2 that we started with, and the result, x plus 7. So synthetic division, it allowed us to substitute a 2 into the function and get a result of 0. That's substitution, but it also allowed us to factor, and the x minus 2 into this left us with an x plus 7 and no remainder. So that's synthetic division.